So in the last lecture, we have seen formula to find Karl Pearson's product moment coefficient of correlation for two variables. So this is one formula, covariance of xy upon sigma x means standard deviation of x into standard deviation of y. Second formula is this, summation x minus x bar into y minus y bar upon in the first square root summation x minus x bar bracket square into in the second square root summation y minus y bar bracket square. And third formula is summation xy upon n minus x bar into y bar upon in the first square root summation x minus x bar summation x square upon n minus x bar square into in the second square root summation y square upon n minus y bar square. Then we take one problem. Calculate product moment coefficient of correlation from the following data. Here given summation x minus x bar into y minus y bar is equal to 29. Then summation x minus x bar bracket square is equal to 28. Summation y minus y bar bracket square is equal to 42. So here we know that formula to find Karl Pearson product moment coefficient of correlation. If this type of data is given, so formula is x minus x bar into y minus y bar upon in the first square root summation x minus x bar bracket square into second square root summation y minus y bar bracket square. So this is formula. So here all values are given. So summation x minus x bar into y minus y bar, which is 29 upon summation x minus x bar bracket square is 28 into summation y minus y bar bracket square is 42. This is equal to 29 upon 1 square root of, this is square root of, this is also square root of. If we take product of these two, we get 34.293 and final answer is R is equal to 0.846. So value of R is this. Then we take next form, Karl Pearson's product moment coefficient of correlation using change of origin property. So sometimes value of x and y are large. So to simplify the calculations, we define new variables u and v as u is equal to x minus x naught and v is equal to y minus y naught, where x naught and y naught are constants. So formula is summation uv upon n minus u bar into v bar divided by in the first square root summation u square upon n minus u bar square into in the second square root summation v square upon n minus v bar square. So suppose we take this problem, calculate Karl Pearson's coefficient of correlation for the following data. So here values of x and y are given, this solution. Suppose let u is equal to x minus x naught, where we consider x naught is suppose 103 and v is equal to y minus y naught, where suppose y naught is 84. Then x, y, u is equal to x minus x naught, v is equal to y minus y naught, Then we know that our formula is this: r is equal to u v upon n minus u bar v bar upon square root of summation u square upon n minus v bar square into square root of summation v square upon n minus v bar square. So here we require product u into v. So here we calculate u into v. Then we require u square, then v square. So here x102, 101, 103, 105, 104. These are values of x. Then values of y are 84, 85, 82, 83, 86. Here we want total, means summation of these. So we calculate total. If we calculate these total, first we calculate u is equal to x minus x naught. So here x is 102 minus x naught, which is 103. So 102 minus 103 is minus 1. Then 101 minus 103, which is minus 2. Then 103 minus 103, which is 0. 105 minus 103 is 2. Then 104 minus 103 is 1. If we add summation u, we get summation u is equal to 0. See here, minus 1 into minus 1 plus minus 2 is minus 3, and here 2 plus 1 is 3. So the minus 3 plus 3 is 0. Then for v, y minus y bar, so here y is 84 and y bar is again 84. So 84 minus 84 is 0. Then 85 minus 84 is 1. Then 82 minus 84 is minus 2. 83 minus 84 is minus 1. 86 minus 84 is 2. If we add these values, we get again 0, 1, minus 2, minus 1, 2. So if we add, we get 0. Then product u into v. So here u is minus 1, v is 0. So 0, minus 2, 0, minus 2, 2. Minus 2 plus 2 is 0. Then here summation uv is minus 2. Then u square, minus 1 square is 1, minus 2 square is 4, 0 square is 0, 2 square is 4, and 1 square is 1. So its addition is 10. Then v square, 0, 1, 4, 1, 4, and its addition is again 10. So use our formula. R is equal to summation uv upon n minus u bar into v bar upon, in the first square root, summation u square upon n minus u bar square. In the second square root, summation v square upon n minus v bar square. If we use all these values here, we get minus 2 upon 5 minus 0 into 0 upon, in the first square root, summation u square is 10. Value of n 1, 2, 3, 4, 5. 5 pairs of observations are given. Minus 0, because u bar, as u is 0, you can easily check that u bar is summation u upon n, so 0. Similarly, v bar is again summation v upon n, so 0 upon 5 is 0. So Here also summation v square is 10 upon 5 minus v bar square is 0. So this is equal to minus 2 upon 5 upon here root 2 into root 2. So this is equal to minus 2 upon 5 into root 2 into root 2 is 2. So this is equal to minus 1 upon 5, and minus 1 upon 5 is equal to minus 0.2. So value of r is minus 0.2. This is our final answer.